All right, so weather occurs, of course, in the atmosphere, so that would be an excellent place to start our discussion. So, we're going to talk about the atmospheric structure and composition. So, again, an atmosphere is just an envelope of gases that surrounds a body, including Earth. And without an atmosphere, we would have no oceans. And so, that's one of the things that makes Earth unique. So let's first talk about the composition. If we would just go down to, say, the mall and ask 10 random people that we ran into what they thought the most abundant element in the atmosphere might be, I'm guessing, I would say 6 out of 10, maybe more, would tell you that it's oxygen because that's what we breathe. That's really important. But of course, you're going to now know, or may already have known, that nitrogen by far is the most abundant element in Earth's atmosphere. And you do need to know that it is 78% compared to 21% oxygen. And then the next most abundant is argon. And then you don't need to know the other trace amounts of everything else. But just keep in mind that everything else that's in the atmosphere makes up less than 1% combined. So overwhelmingly, our atmosphere is nitrogen, followed by oxygen. And it wasn't always that way, right? So early Earth's atmosphere was not hospitable to life. It contained little to no oxygen. And so, here's kind of a graphic here that will tell you about a little bit how that process of oxygen being added to the atmosphere came about. And we owe a lot to a thing called a stromatolite. So, bacteria whose byproduct is oxygen. Thankfully for that, more and more oxygen over time has been added to the atmosphere through various processes. So recently, of course, the concern has been the increase in carbon dioxide levels in the atmosphere. And you can see that it has steadily risen. You can see in this graphic from 1960 to 2010. And you're seeing the peaks and valleys, the high and the low points are reflective of the seasons. So you will see some seasonal variation, but in general, obviously, the trend is going up. So let's talk about atmospheric, or what you might sometimes hear called barometric pressure. And that's the pressure exerted by the Earth's atmosphere above at any given point. And so it's basically, think of it as a column of air and how much pressure is exerted on a particular area. Okay. And of course, that pressure decreases with height or altitude. And sorry, it's blocking your view there. Not going to get around that. It is measured in millibars. Okay, so the unit of measurement that we'll typically see is millibars. All right, so we're going to look at the structure or layers of the atmosphere, and those layers are basically separated by what is the temperature in that layer doing. And so if you've ever, climbed a mountain or been in a mountainous region, or common sense tells you that when you go up the mountain or increase your altitude, the temperature decreases. That's what we would expect it to do. We're moving away from the warm Earth. But you'll see here by the blue and red arrows that the stratosphere, the temperature increases, and then it decreases in the mesosphere, and then finally increases in the thermosphere. So again, it's based on what is going on with the temperature in that layer. So let's start with the troposphere. That's the lowest layer, the layer we live in. And again, as I mentioned, as you go up in altitude, you decrease the temperature. It's also where weather occurs. So obviously a really important layer in terms of what we're discussing. The stratosphere is where ozone, fortunately, is located. I say fortunately. The oxygen you breathe, the air you breathe is a mixture of gases, but the oxygen you breathe is O2. Ozone is O3 and toxic if you were to breathe it. So luckily, most of the time it is living in the ozone. So because of the presence of ozone and the fact that it absorbs some of that incoming solar radiation, the temperature in the stratosphere actually increases with altitude. Moving on to the mesosphere. Meso means middle, so it is one of the middle layers. The temperature in this layer decreases with altitude. Nothing really otherwise notable about the mesosphere. The thermosphere is the highest layer. It is where satellites are located, and we see the temperature increasing with altitude here. Also within the thermosphere, we have the ionosphere. And ions, of course, are just charged particles. Sometimes this reacts with the solar wind coming from the sun, and it produces these things called the aurora borealis, or the common name is the northern lights. And there's a picture that's pretty representative of what they look like. The reason they're called the northern lights is you don't typically see them as far south as we are, so we're at about 39 degrees north latitude. That would be pretty far south to witness the auroras. So that's just basically the structure and composition of Earth's atmosphere.